Hello everyone. We are Group 15 presenting on driverless freight trucks. So when we look at the mechanism section of a poster, we are looking at the culmination of a century of automotive evolution. For decades, the truck was a mechanical beast. It consists of an engine, a transmission, and a driver. Today, that paradigm is dead. We have entered the era of the ghost drive. This is not merely a truck with a cruise control system, it is a sentient logistical entity. So, to understand the ghost drive, we must understand the sensory hierarchy. In biological terms, a human driver has a field of vision of roughly around 180 degrees, limited depth perception at high speeds, and also reaction time of approximately 250 milliseconds. But the Ghost Drive, however, operates with a 360-degree digital consciousness, sub-millimeter precision, and a reaction time measured in nanoseconds. So, this transition from biological limitation to digital perfection is facilitated by a stack of hardware and software that we call sensor fusion. At the apex of a diagram sits LIDAR, which is light detection and ranging. While the public often confuses this with simple cameras, LIDAR is a fundamentally different one. It is an active sensor. It does not wait for light to hit it, it creates its own light. By pulsing millions of infrared laser beams per second, it measures the time of flight for each photon to bounce off an object and return to the sensor. In an autonomous haulage context, this allows the truck to generate a high density 3D point cloud. Imagine a digital ghost of the world around the truck, where every crack in the pavement, every leaf on a tree, and the exact distance to a leading vehicle is known with absolute certainty. We use around 1600 nanometer wavelength lasers because they offer superior range and are very eye safe. So LiDAR provides the structural truth of the environment. Unlike a camera, which can be fooled by a realistic painting of a tunnel on a wall, LiDAR knows that the wall is a solid object because the light pulses return instantly. It is like the structural brain of the ghost drive. And to the right, now we have radar. If LiDAR is the eyes, radar is the intuition that works when the eyes fail. So radar, it uses radio waves, specifically in the 77 gigahertz to 79 gigahertz spectrum. Why is this critical for autonomous haulage? It is because long haul logistics happen in the real world. They happen in torrential rain or in thick fog in the Central Valley and in some blinding snowstorms in the mild Midwest. LiDAR and cameras can be obscured by particulate matter in the air, whereas radio waves pass right through. So, our radar systems utilize frequency modulated continuous wave technology, and this allows the truck to not only detect an object but to instantly calculate its relative velocity. It is calculated through Doppler effect. So, for suppose if a car 200 meters ahead is slowing down by 5 kilometers per hour, the radar knows it before the human eye could even perceive a change in the brake lights. With this, it creates a safety buffer that allows the truck to maintain optimal distances without risk. And thirdly, we have the camera arrays. While LiDAR gives us the where and radar gives us the how fast, this camera it gives us the what. This is the semantic layer. Through high definition multispectral camera systems, the truck's AI it identifies the world and it distinguishes a stop sign from a yield sign. It recognizes the difference between a police car's flashing lights and a billboard's neon glow. We employ deep convolutional neural networks to process these images in real time. This involves pixel level segmentation, where the AI labels every single pixel in its field of view road, sidewalk, vehicle, pedestrian, obstacle, or anything else. This layer is crucial for navigating the hub to hub model. where the truck must recognize lane markings and traffic signals with 99.99% reliability. Central to the poster is the AI chip. This is the brain of this. This is not a standard CPU. This is an ASIC or a high-end NPU. ASIC, it stands for Application Specific Integrated Circuit, and also NPU stands for Neural Processing Unit, and they are capable of trillions of operations per second. The role of this chip is sensor fusion. Data from the LiDAR, radar, and cameras is streamed into this central hub. The AI must perform temporal alignment, and it must ensure that the image from the camera and the point cloud from the LiDAR represent the exact same millisecond in time. The chip runs a world model, a simulation of what will happen in the next 10 seconds. It predicts the trajectory of every surrounding vehicle. If the world model detects a 5% probability of a collision, it preemptively adjusts the braking pressure. This is called edge computing at its finest. The truck does not wait for a cloud server to tell it to the brake. The decision is made locally at the speed of light. And finally, we have V2X connectivity. An autonomous truck is never truly alone. Through V2X, which is a vehicle to everything, the truck enters a dialogue with the infrastructure. It communicates with smart traffic lights to optimize its approach speed, ensuring it never has to come to a full stop, saving it saves massive amounts of fuel, and also it communicates with other trucks to facilitate platooning. When the lead truck encounters a pothole, it sends a digital warning to every truck following it. This collective intelligence means that the fleet is smarter than some of its parts. This is the nervous system of the logistics frontier. For the next section, I would like to call my next teammate.
Thank you, Manasa. Now that we understand the hardware, we must address the so what. Why are we spending billions on this technology? The answer lies in the supply chain and operations impact section of our poster. For a century, the primary constraint of the global supply chain has not been the speed of the truck, but the biology of the human. A human driver is a marvelous biological machine, but it has a fatal flaw in a 24 by 7 economy. It needs to sleep. In the United States, hours of service regulations strictly limit a driver to 11 hours of driving within a 14-hour window. This means that for at least 10 to 13 hours every day, a $200,000 asset sits idle in a parking lot. This is asset rot. Look at the lead time reduction graphic on our poster. In a traditional human driven model, a cross country haul might take 10 days. This is not because the truck is slow, but because the truck is resting. When we remove the human driver, the truck becomes a continuous flow asset. It drives 22 hours a day, stopping only for fuel, inspections, and sensor cleaning. By cutting the lead time from 10 days to 5, we are not just getting goods to customers faster, we are fundamentally changing the financial structure of the shipping company. In finance, we look at the cash conversion cycle. When goods are in truck, they are inventory in transit. They are debt capital. By halving the transit time, we double the velocity of that capital. For a company like Walmart or Amazon, reducing transit time by 50% across their entire fleet releases billions of dollars in liquidity that was previously trapped on the highway. The bar chart on the poster shows a jump from 29% to 80% utilization. In the current trucking industry, the average truck is moving less than 30% of the time. This is incredibly inefficient. Imagine a factory that only ran its machines for 7 hours a day and left them off for the other 17. You would fire the manager. Yet, this is how the entire logistics industry operates today. Autonomous haulage allows us to achieve what we call high intensity asset utilization. An autonomous fleet can handle 3 times the volume of a traditional fleet with the same number of vehicles. This capacity expansion means that as global trade grows, we don't need to clog our highways with more trucks. We simply need our existing trucks to work harder. But we are moving from a volume based growth model to a velocity based growth model. Let's talk about resilience. The global supply chain is currently facing a catastrophic driver shortage. In the US alone, the industry is short of 80,000 drivers, a number expected to double by 2030. The average age of a long haul driver is nearly 50. Younger generations do not want this job. They do not want to be away from their families for weeks at a time, sleeping in cab bunks. Autonomous haulage is the safety valve for this crisis. By automating the long haul, the monotonous interstate driving, we allow the remaining human drivers to focus on short haul and last mile deliveries. This makes the job of a driver more attractive. They get to stay local and go home at night when the machines handle the grueling 1,000 mile stretches. This creates a resilient supply chain that is immune to labor strikes, aging demographics, and pandemic related shutdowns. Finally, safety is not an ethical concern, it is an operational one. A single major accident can shut down a highway for 12 hours, delaying thousands of shipments and costing millions in lost productivity. Our poster notes that autonomy reduces human error by 94%. For the our, human error, distraction, fatigue, and speeding is responsible for 94% of the accidents. By mitigating these risks, we ensure a constant throughput. We no longer have black swan events disrupting our delivery schedules because a driver fell asleep at the wheel. In the eyes of a chief operating officer, an autonomous truck is a deterministic asset. You know exactly where it is, exactly when it will arrive, and exactly what it is doing. This level of predictability is the holy grail of operations management.
Now my friends have established the how and the what. I am here to discuss the capability, specifically how autonomous haulage fundamentally breaks the 100-year-old linear model of logistics. The first icon in our business capability box is 24/7 continuous flow. To the uninitiated, this sounds like a simple increase in hours. To a business strategist, it is a total reimagining of supply chain. For a century, logistics has been pulsed because human drivers are bound by biological circadian rhythms and strict government mandates like the hours of service regulations. Goods move in fits and starts. A truck moves for 11 hours, then becomes a static piece of metal for 10 hours. This creates a stop and go economy. When we introduce the ghost drive, we transition to a continuous stream economy. Imagine a river. A river doesn't stop to sleep. It flows constantly by enabling a 168-hour work week per asset. We eliminate the bullwhip effect often caused by logistic delays. When shipment moves continuously, the safety stock required at warehouses drops significantly. Businesses no longer need to buffer against the uncertainty of a driver schedule or the mandatory rest periods that create the gaps in the supply chain. We are moving from batch processing to a real-time streaming of physical goods. Next, let's look at platooning. This is where the V2X connectivity mentioned by Manasa manifests at a massive cost-saving capability. In the traditional world, every truck is an island, fighting the air resistance alone. In an autonomous world, trucks operate as a synchronized unit. Using cooperative adaptive cruise control, 3 or 4 autonomous trucks can follow each other with a gap of less than 10 meters. At 65 miles per hour, the lead trucks brakes the air while the following trucks sit in the slipstream. Our data points to a 10% fuel cost cut. To put that in perspective, for a fleet of 1,000 trucks, fuel is often a 50 million annual expense. A 10% reduction is a 5 million straight to bottom line again. But platooning is more than just fuel savings. It is a capacity multiplier. By reducing the space between the trucks, we effectively increase the density of our highways. We can fit more freight into the same amount of road space without building a single new lane of asphalt. This is virtual infrastructure at its finest. The final pillar is the hub to hub model. We must be realistic. Level 5 autonomy in dense, unpredictable urban centers like New York or Mumbai is still a significant challenge. However, the middle mile, the long, boring, predictable stretches of interstate highway is perfectly suited for missions. The hub-to-hub model uses a transfer-up strategy. A human driver handles the first mile from the factory to a suburban hub. There, the trailer is hitched to an autonomous tractor. That tractor drives 800 miles of highway, never speeding, never getting tired, and never getting distracted. At the destination hub, another human picks it up for the last mile. This model solves the most difficult problem in modern logistics, which is driver retention. By moving humans to the short haul roles, they can be home for dinner every night. Meanwhile, the machines handle the grueling cross country treks. This is a synergistic relationship where the business capitalizes on the precision of the machine and the navigation skills of the human of complex urban environments. It is the most viable path to the logistics frontier.
Thank you. As we move to the OM theories session, it is essential to understand that autonomous haulage is not just a technological upgrade, it is a mathematical optimization of the laws of physics and economics. We aren't just using trucks, we are applying the core principles of operations management to a previously unoptimizable human system. Let's start with the theory of constraints. Popularized by Eliyahu Goldratt, the TOC posits that every system has exactly one bottleneck that limits its total output. If you improve anything other than that bottleneck, you are wasting your time. For a century, the driver's biology has been the bottleneck of the global supply chain. It did not matter how fast the engine was or how efficient the warehouse was. The system was limited by the 12-hour driving window. Autonomous haulage elevates the constraint. By removing the driver's need for rest, the bottleneck shifts from a biological one to a mechanical one. Now, the constraint is the truck's fuel capacity or its maintenance cycle. By elevating the constraint, we increase the throughput of the entire global trade network. We have efficiently widened the pipe through which all commerce flows. Next, look at the equation of the poster. This is Little's law. The average number of units in the system equals the average arrival rate multiplied by the average time a unit spent in a system. In traditional logistics, the average number of units in the system is high because of those 10-day lead times. To keep the throughput average arrival time high, while the average unit time spent in the system is also high. You must have a massive amount of inventory sitting in trucks across the country. This is extremely expensive capital. By using autonomous haulage to slash the lead time from 10 days to 5, we can maintain the same throughput with half the amount of inventory in the system. For a chief financial officer, this is the holy grail. It means you can satisfy the same amount of customer demand while having 50% less money stuck on the road. The mathematical elegance of autonomy allows us to shrink the supply chain while expanding its impact. Finally, we apply lean management. Lean is the relentless pursuit of the elimination of waste. In logistics, we focus on the 8 waste, but 3 are particularly relevant here: waiting, transportation, and motion. Waiting. In a human driven system, a trailer waits for a driver to wake up. This is pure waste. Autonomous trucks eliminate this type of waiting. Second one, transportation. Through AI optimized routing, autonomous trucks eliminate empty miles. Roughly 20% of trucks on the road today are empty, driving to their next pickup. AI synchronization ensures that a truck is almost always hauling a load. Third, defects, safety. In lean, a defect is anything that doesn't meet the standard. An accident is the highest ultimate defect. By reducing human error, we eliminate the waste of damaged goods and insurance claims. We are moving from just in time to continuous in time. By applying lean principles through a digital lens, we ensure that every gallon of fuel and every hour of road time is adding value to the customer. We are not just moving boxes, we are optimizing the entropy of the global economy.
To conclude our presentation, let's look at the value proposition. Everything we have discussed today, the LiDAR, the 24/7 flow, the OM theories, leads to this final box. First, company value. Headline figure is 40% lower TCO, total cost of ownership. To a layman, this sounds like no driver wages, but it is much deeper. It is about maintenance optimization. Because the AI brain monitors the truck's health 1,000 times per second, it can predict a part failure before it happens. This is productive maintenance versus reactive repair. It prevents catastrophic engine failures on the side of the road, which are 10 times more expensive than scheduled shop visits. Then there is lower insurance. Insurance is a game of probability. As the data proves that an autonomous truck is 10 times safer than a human driver, the risk profile the risk profiles will shift. We expect insurance premiums to plummet for autonomous fleets, further widening the gap between modern and legacy logistic companies. Finally, 2x asset utilization. We are making our capital work twice as hard, effectively doubling the return on assets for every vehicle we own. But a company only prospers if the customer wins. For the customer, the value is threefold. In the age of e-commerce, speed is the primary differentiator. If we can deliver a product in 3 days instead of six, you win the customer. Economics 101 tells us that as the cost of production, shipping drops, the price to the consumer eventually drops to competition. This lowers the cost of living for everyone, as almost everything you own was once on a truck. Customers no longer want to see package is at facility X. They want to see the truck moving on a map, the temperature of their perishable goods, and the delivery time accurate to within a 5-minute window. Autonomy provides this digital transparency natively. We are standing at the logistics frontier. We are transitioning from a world of best guesses to a world of precise execution. Autonomous haulage is a bridge to that future. Thank you for your time.